Hello humans, welcome back to Let's Learn Python on Code with Connor. This is Unit 3, topic number 3, where we're going to continue our work with functions. Before we do that, we're going to jump back to our previous lesson where we had a pretty tricky challenge out there. Let's quickly recap what the challenge was, and then we'll dive into the code to see how we made it happen. So for our challenge last time, we had this little menu with our turtle window. We had a few functions. So if I chose A for draw square, I could enter a length, draws the square. I have a D option to clear the screen. I have an E option to move my turtle to a new X and Y position. So move it down to -300, -300, and then I can take over and draw something else. So I could draw a triangle now, draw a big triangle. I could clear my screen, and let's move my turtle over a little bit. So we'll keep him at -300. We're going to move over to -200, and we'll draw a polygon with 8 sides. That's 400 long. And we're going to go off the window here, but that's all right. Comes back together. And then we clear the screen. And we move our turtle back to the center. There he is. And I can continue with this process. You see how it works. So this was the program that we were building. When I hit Q, quit the program. So let's have a look at the code and see how we actually did it. So I already showed you a little bit. I showed you that we import the turtle, we set up the screen, we set up Timmy, he's our turtle. We set up his pen size, it's 8. You can make it different if you wanted. And then I created this little menu string. Okay, that's just 3 quotes, some dashes, and then the menu. I have a bunch of functions. I have draw polygon. This is the most complicated one though. There's definitely a cleaner math way to do this using exterior angles. I don't know why when I was writing the code, my brain was hardwired for interior angles of polygons, so I use the interior angles and then turn them into whatever. It doesn't matter. You got to look at the math for how to do this. But basically, using num sides, I can calculate what that turn angle is going to be. Yeah, that exterior angle in order to move me to the next line, which is what it is. It's called the exterior angle of a polygon based on the number of sides. So look that up. So for I in range num sides, draw the one of the length and then turn left by that angle. So that was my draw polygon. Draw triangle was just for I in range 3, forward and then left by 120. That makes an equilateral triangle with an interior angle of 60 degrees. Then draw square, take X, do for I in range 4, forward by X, and then left by 90. And then the big user menu. This is where all the real code happens. We do a while true, we print our menu. We take user input, which I called choice, and we do a dot lower. This just means that if they accidentally enter a capital letter, it'll shrink it down to a lowercase before it compares it in our if statements. Just nice. Then I start my if structure. If choice is A, and if we just collapse these, you can see all of the choices I have. If choice equals A, elif choice equals B, elif it's C, D, Q, and E. I got them out of order here, but it's all right. And then I have an else at the end. You can imagine that else at the end is just prints invalid entry, continue, which restarts the loop. You can imagine quit is thanks for playing, and then breaks out of the loop. And then all the other ones are going to ask the user for that side length, store it. So choice 2 is now int input. I want it to be an integer. And then I'm going to call the draw square function using that number. If I go down here, enter the side length, same code. Because this choice 2 and this choice 2 can't see each other. They're each inside their own blocks of code. So that works out great. And again, they can't both run at the same time. If the if runs, the elif doesn't, and so on. Okay. For C, I had to ask for 2. So I asked for num sides, and I asked for choice 2. And then I did draw polygon, and I passed it both parameters. Choice D just calls Timmy.clear. Nothing fancy there. Choice E asks me for an X and a Y variable, lifts the pen up, does a set position X and Y. You'll notice this function is not ours. It's in the turtle library. It also takes parameters. It takes an X and a Y. And then I put the pen back down to be ready for the next draw command. And then at the very end of my code, I call user menu. This is actually the first line of code that executes because it reads all of this. Okay, sorry, technically these lines execute first. Sorry. So sets up the turtle, sets up the window, sets up the pen size, creates a string, and then tucks away all the functions for later, and then bam, at the end calls user menu, which triggers all of the rest of the code execution from there. So that's your challenge. from Unit 3, topic number 2. It was a big one. Hopefully it went well. We're going to actually pull this back up when it comes to project time at the end of the unit. So let's talk about functions that return a value. This is topic number 3. So far we've been creating functions that don't take any parameters. We've also been creating functions that do take parameters. Now we're going to talk about functions that give something back to you when you call them. So a function that gives something back is called a function that returns. So we're going to look at this little function here. I import math. I have 3 functions. One's called area of circle, takes a value r. One's called area rect, takes a length and a width. One's called area of square, takes an s. Okay, and it uses this reserved word called return. Return, and then it returns something. This is math.pi times radius squared. This one's length times width, and then side squared. So the way returns work is this. When you think about program execution, when you call a function, you're telling the code to jump to a different code block and execute everything inside of that code block, and then return back to where you called it from to continue execution for the rest of the program. When you call a function with a return value, what happens is when you send it off to do something, it's going to send you an answer when it comes back to where you called the code from. I'm going to call area circle with 5. And what happens is when I go and call that, it's going to jump up here, put a 5 in R, run this code, pi times 5 squared, get an answer, and return that answer back to where I called it. So this area circle 5 is actually going to get replaced with the value that got returned from the function. So what you're doing is essentially using functions to represent values, because those functions are going to return a value after their code has executed. Okay, so I've sent off to the area of a circle function. It's going to send back an answer. But all I need in my code is that call to the function. And when the function comes back or returns to me, that function call will be replaced with the actual value. So it might be a number or a true or a false or a string or something else that gets sent back to me as a return from that function that I called. So that's why I put this in a print statement. If I didn't put that in a print statement, then it's going to go find the area of a circle with a radius 5, and it's going to yell back the answer to me, and I'm not even going to be listening. I'm just going to be moving on to the next code execution. Instead, by putting it in a print statement, I've said, hey, I'm listening. I've told you to do something, and I'm going to sit here and wait for you to do it. And then once you've done it, I'm going to use what you've given me or what you've returned to me to continue my code. So I'm going to take the answer from this, and then I'm going to print that answer. Or area of square 10. I'm going to go call area of a square, send it a value of 10. It's going to do 10 squared, and it's going to return 100. And then I'm going to print 100. And if I sent it a different number, it would print a different number. So this is that call and return structure of functions. You don't always have to write functions that return. Sometimes you just want a function to do something, right? Maybe it's drawing turtle graphics and not actually needing to give you a value back. But depending on how you structure your larger programs, having a function return something might be really helpful. So that's how the return structure works. Now you'll notice I've returned actual math operators here. You can also just return a variable, or you can hard return a single literal value like a string or a true or a false or a number. It doesn't have to be some other math equation or anything like that. Heck, you can return the value that gets returned from another function. That gets interesting. Okay, so this is how the return stuff works. If I run this, it should print the area of a circle with a radius 5, and it should print the area of a square with side length 10. So I see the area of the circle with radius 5 and the area of the square with side length 10, and they print out to the screen. This is a basic understanding of how the return stuff works when we're dealing with functions. Now, we're going to talk later on about when you have to design a project or a program to do something. How do you decide on the layout, and how do you decide on, what functions am I going to need? Are they going to return? Are they not going to return? And that's all part of developing software development skills, is understanding that class design or that program design piece around, okay, how am I going to make this work? Am I going to need a bunch of functions? What are those functions going to need to do? Are they going to need to return something to me? Are they not going to need to return something to me? And figuring all of that out is going to be something we do deeper in the course. Now we're going to jump into the challenge for Unit 3, Topic 3. this challenge shouldn't be too bad. And we're just going to take a program we've already written, which was the one when we first learned if statements about whether you're old enough to drive, old enough to vote, old enough to consume alcohol cannabis in Nova Scotia. And we're going to rewrite that using a return structure on our functions. So it's still going to run the same way as before. Let's say I'm an adult and I'm 25. It's going to print all three statements. So you're old enough to purchase alcohol and cannabis, vote, and drive. And again, you can adjust the ages for your location. And then if I enter a lower age, so I'm 18, well, I can vote and I can drive. If I enter a younger age, like 17, I'm old enough to drive. And if I enter a younger age, like 15, it doesn't print any of the statements. So just some modification on a program we've already written. If you look at the code, I'll show you just a little bit. I've created these functions for alcohol, cannabis, a function for vote, and a function for drive. They each take a variable, which is probably going to be age. I'm going to ask the user for age, and then I'm going to use my if statements, and I'm going to use return values for my functions. So I can get my functions to return true or false, and then based on the true or false that they return might impact the if statement conditional that I use when I'm actually doing my print statements. So see if you can get that to work the same way as it did before, but using this function call and response or call and return structure that we're doing in this lesson. And that's it for another lesson. This is a quick one. If you pulled off topic 2, you should have pulled off topic 3, and you should feel pretty good about yourself. You're an awesome human, I assume. Again, I don't actually know. But thanks for sticking with the course. Like, share, subscribe, do all those things, and we'll see you back in the next lesson. See ya.